So we have a number of statements within here. So we have the user agent statement at the top, and then we have a number of allow and disallow statements. So I'll cover those in detail now. The user agent directive essentially specifies the behaviour of an individual bot, sorry, an individual robot. So what we can have here is we can use an asterisk to apply to all spiders, robots or crawlers. Or what we can do is specify a particular user agent. So in this case, the specification for the Googlebot is obviously Googlebot. So we can then say for your particular robot, this is how I expect it to behave when it comes to retrieve content from my web server. And we also have the next directive, which is probably the most important one, is the disallow directive. Now what this essentially does is say from any path that's on my web server from here on, do not put your robot down there because it's either quite a significant amount of content or the content is dynamically generated, so it will actually impact the capacity that my web server can serve web pages at. Now, in specific to Google's thing, they've obviously put the news, search, groups and images, which obviously for them is updated quite continuously when new content is indexed. But the important thing with the disallow directive is to not use it for actual access control because it can be intentionally ignored by robots. So there are some robots out there that will actually look for the disallow directive and then essentially apply heuristics to the content and then sort of retrieve the content from there. The other thing too, especially in relation to Google, is you can't use it for, don't rely on it for digital rights management in terms of how your content is actually published by third parties. If you don't want your content published, use the access control mechanisms within the actual web server itself. So essentially once the content's released, you've got to have a method of pulling it back. So there is Google do actually provide a tool to test how the actual robots.txt file is and how it's actually inspected by Googlebot, and that's done through the Webmaster Tools, and that itself simply is done through the dashboard. You just click on the URL that you've added to your Webmaster Tools, click on the tools from there, and then you just click on the Analyze Robots.txt file. So it provides you with a spiffy HTML or web interface to be able to check content from there. Any questions? Okay, so I'll now cover the Search Engine Discovery Reconnaissance section of 4.2.2 of the OWASP Testing Guide version 2. Okay, the current methodology for Google hacking at the moment is to actually run single search queries. So what we have here is a number of queries that will pull up content. So for instance, to pull up Microsoft Remote Desktop Web Connection, we use the Untitled search operator from Google, which essentially will find content within the HTML title, and the content we're looking for there is the Remote Desktop Web Connection, and within the actual URL, which is specified by the Google in URL search operator, is tsweb. To find virtual network computer Java applets, we look for VNC desktop, and in the URL we're looking specifically for TCP port 58,000. And for Outlook Web Access, we again use the in URL, which will find locate content with specifically that URL. So in this case, we're either looking for exchange/login.asp, or we can look for the in title because there's two versions of Outlook Web Access. So we can look for, obviously, within the title of the HTML document, Microsoft Outlook Web Access Login. And finally, we can locate PDF files or a number of other different file extensions. So for instance, to locate PDF, we use the file type operator. Now, the problem with using this methodology is Google have essentially cottoned on to this and are now basically returning we're sorry for specific searches that you try and run. Now, the reason that they do that is to basically stop people or automated worms and like Sasa and those from searching Google to locate vulnerabilities. Now this goes back to the Rise of the Robots paper in FRAC, which essentially meant that you would retrieve content from a web server, store it somewhere, and then when vulnerabilities became known, you would then go back to that content and mine it and then be able to launch your exploit from there. Now, every time we get one of these "we're sorry" return pages, it actually impacts what's known as the Google Soap Search API key, okay, which is, I'll cover later on, which is part of the download index cache project. And so that essentially means it reduces the amount of effective searches we can drive with our API key. If you do actually want to read a paper on this, Google have actually published one by Niles called Search Worms. I believe it was presented at Usenext, but I'm not quite sure. But you can locate it on Google, obviously, by searching in those terms. Now, there is actually ways around this "we're sorry" screen, and essentially what it means is we launch different search queries, but they return overlapping results. So you were able at one stage to actually polymorphic sort of your search query. So if you changed for like a PHP and you change it to lowercase p, uppercase h, lowercase p, Google would return the results. They're now actually applying some sort of polymorphism to it to basically do sort of simple regular expressions, but not to the point where it's actually impacting what Google would do for search results, because obviously they want to return the results as soon as possible, and it would therefore impact their business. So it is possible, if you run these if you run your queries by hand first, find out which ones you return are "we're sorry," and then you modify the queries before you load it into your tool, then you can get round this section. Or sorry, you can get round this being returned.
Sorry, a question?
Yes?
I might have missed out on something, but what's the goal of this? Are we trying to find vulnerabilities by Googling stuff, or are we just...
No, I'll actually cover the methodology in terms, but the previous goal...
Why are we doing Google hacking?
From an OWASP standpoint?
From every standpoint.
Well, okay, that's an interesting question, because I'm actually a reverse engineer by trade. I don't generally do this stuff. In terms of this coming into OWASP, I actually did a presentation at an ACM Computer Security Day back in November of 2007. I then presented this in Australia, and that's how the project sort of started from there. To actually do it is to actually locate vulnerabilities that you don't find with traditional port scanning or that kind of thing. So you can use Google as kind of like an anonymous proxy in terms of actually locating content without just revealing your client IP. And the way you actually do that is to look at the cache page and then apply the strip1 parameter to the search from there. But essentially, if you're looking for vulnerabilities on a client site, you can use this as a way of actually finding it without, I guess, physically touching their infrastructure. The other reason for looking at Google is if you reverse the search results and you start from, say, the last result returned and then recursively go back from there, you'll actually find content that's probably not meant to be public or is less public and less popular. So that's where you'll also find a lot of your information leakage and that kind of thing. There is actually, you probably want to look at the one I did at Australia. That actually goes through the background of it. I would have done that today, but